Welcome to this video tutorial on testing a mean and proportion. We're going to start with testing a mean by attempting problem number 2 in problems 5b. So the problem reads, the weights of chocolate bars are described on the wrappers with a message claiming that the mean is not less than 50 grams. The data below show the weights in grams of a random sample of 6 of these bars. Use these data to test the claim about the mean weight. So, as usual in a hypothesis testing problem, we'll begin by stating the null hypothesis, H0, which in this case states mu equals 50. So that's the statement of the null hypothesis, mu equals 50. The alternative hypothesis is what would lead to rejection, H1, the alternative hypothesis. In this case it says that the bars are described with a message claiming the mean is not less than 50. Therefore, a mean of less than 50 would lead to rejection, but a mean greater than 50 would not. So the alternative states mu is less than 50. Only a departure on the lower side would lead to rejection. So this will be a one-tailed test. Next, we take the data and calculate the sample statistics. There are 6 data points here, so n equals 6. We can enter these data into our calculator in stat mode, and pressing the X bar key gives us the sample mean, 49.818. X bar equals 49.818. We have to round the numbers somewhere. I'm rounding them here at 3 decimal places. Pressing the standard deviation key gives us the sample standard deviation estimate S equal to 0.222. So now we have the sample statistics calculated. Next we want to calculate the test statistic T. So T, the test statistic, is X bar minus mu. By how much does the sample mean differ from the hypothesized population mean, divided by the estimated standard error of the sample mean, S over root n. So we take the statistics we have calculated here and we substitute them into this formula using, of course, mu equals 50 as in the null hypothesis stated above. So in this case, T equals 49.818 minus mu, which is 50, divided by S, which is 0.222 over root 6. Putting that into our calculator, we get that T is minus 2.008. So there we have the calculated value of the test statistic T. It now just remains to see, does that fall into the rejection region or the acceptance region? Because n equals 6, we have n minus 1, that's 5 degrees of freedom. So the degrees of freedom is 5. So now we're going to go to the T tables and see what is the critical value of T with 5 degrees of freedom. So T distribution has the same bell shape more or less as the normal distribution. 0 will be in the middle. The alternative says less than. So it's the less than tail, the left tail, that leads to rejection. And there's just a single tail. So we want to know what is this critical value, which cuts off 5% of the distribution in a single tail. So going to the tables of the T distribution, we get, with 5 degrees of freedom and one tail, the 5% point, the critical value is 2.015. Now, because we're in the left tail, we know that that must be minus 2.015. So anything above is in the acceptance region, anything below is in the rejection region. Our calculated value is actually very close, minus 2.008, so it's just inside. But the fact that it's inside means the decision is made, and this is the real advantage of a statistical hypothesis test. In a case where there's uncertainty, or where there's a conflict between a producer and consumer, it gives a clear rule for making a decision. And so because the calculated value of t falls into the acceptance region, we say that we accept the null hypothesis. And in this case, that means that the claim made on the wrappers is accepted. So we'll just write that in words. The claim is accepted. So here we have used some sample data to arrive at a verdict in relation to a population mean by drawing a sample and performing this t-test. So you might want to pause this video now, because now we're going to move on and we're going to test a second type of hypothesis. And this time it's problems 5b still, but this time number 4. And this will be a one sample p-test testing a proportion. So the statement of the problem says it is claimed that at least half of the passengers who use the Galway to Dublin train are business travellers. A random sample of 220 passengers was taken on this route, and just 92 of the sample passengers were found to be business travellers. Use a hypothesis test to investigate if the claim can be accepted. So again, as always, we begin with our statement of the null hypothesis. The null hypothesis on this occasion is making a statement about the population proportion. It says that the proportion of the passengers is at least half. So the null hypothesis must state a particular value for the parameter. So we'll just say it is half. And we'll deal with the at least half in the next step when we look at the alternative hypothesis. So pi equals 0.5. The population proportion is 1/2, is what the claim states. If the null hypothesis is rejected, it is rejected in favour of the alternative hypothesis, H1. What would lead to rejection would be if it were less than half, because if it's half, the claim is true. If it's greater than half, the claim is true, but if it's not half, then the claim is rejected. So the alternative hypothesis always represents what would lead to rejection of the null hypothesis. So if pi is less than 0.5, the claim will be rejected. Okay, so we now record the sample statistics. N is 220, the sample size. The sample proportion P is 92 divided by 220. And 92 divided by 220 as a decimal is 0.4182. 4182, which you might notice is around 42%. So that seems to be less than 50%. However, the theory is not disproven at this point, because if the population proportion is 50%, then some samples will have less than that and some will have more than that. So we now calculate the test statistic. Z equals P minus pi, the difference between the observed sample proportion and the hypothesized population proportion, divided by the standard error of the proportion, pi into 1 minus pi over n. And into this formula we substitute the sample values that we have on this occasion. So in the numerator we have 0.4182 minus 0.5, and in the denominator we have the square root of 0.5 times 1 minus 0.5 divided by 220. And when we calculate that quantity, we get Z equals minus 2.4266. Again, the next step is to go to the tables. The test statistic is Z, so it's a normal score, which we will find on the final row of the t-tables. And in particular, the alternative on this occasion is a less than. So it's a one-tailed rather than a two-tailed test. It's Z, there's the middle, and it's the left tail that will lead to rejection. Not both tails, not the right tail, just the left tail on this occasion. So it'll be minus something. So we want to know what is the critical value of Z at the 5% point for a single tail. So going to the tables of the t distribution, which also includes the normal distribution, and going to the final row, t infinity is Z, and 5%, 1.645. There's a two-tailed value, but this is the one-tailed value. One tail contains 5%. 1.645 is what the table suggests. We know that it needs a minus in front of it because we know that it's the left tail that leads to rejection. Minus 1.645 is the critical value. The calculated value is minus 2.42, so it's clearly more extreme than that. It's in the rejection region. So our conclusion on this occasion is to reject the null hypothesis. So we want to investigate this claim at least half the passengers. On this occasion, we said the claim is rejected. This is rejected in favour of this. Having examined the sample data, we have come to the conclusion that the proportion of business travellers is less than 50%. So we'll just say the claim is rejected. It's important to state the conclusion in language that can be understood by someone who's not qualified in statistics, because you want the conclusions to be available to your client or the general public. So the claim is rejected in that case. So there are additional problems you can attempt in problem set 5b, and of course you can always check your answers by referring to the answers provided in the appendices.